Yeah, thank you. So I'm Paul Massana. This is going to be a bit of a different, a change of topic now. We've been hearing a lot about high energetic events. So now I want to veer towards the stellar, more classical side of things, in which I'm going to talk about this project that we have with the NOIRLab source catalog. So for this project I'm working on with David Neither, who's also here, PI of the NSC, and then two grad students, Brett and Neil, and then Clara Martinez Vázquez from Gemini and Kathy from NOIRLab, where I'll also be working for in the next few months. Um, so this is sort of an ongoing project right now. So it's going to be more of a, since this is a sort of a hands-on sort of conference. I'm going to be talking about a project that it's ongoing. So most of the stuff that we'll see is sort of project ongoing efforts. So since I'm the first person in this conference to talk about the NSC, I have like the pleasure to introduce a little bit of a few things about the NSC. So the NSC basically uses all of the publicly available data from what formerly was NOIO, but now it's like some of the or most of the NOIRLab facilities. And so there's a poster by David Neither, well, David is also there, but then there's a poster there right at the end, where there's a bit of an introduction about the NSC as well. But basically, we have over 400,000 exposures in the second data release. There's about 7 years of DECAM data, which is the main contributor to the NSC in terms of data size. And so this is up to, I have notes here, it says up to October 2019. So this data release now is sort of getting a little bit old in the sense that now there's many more data to use, and so the third day release is going to be coming, is under preparation, has been under pressure for a while. So it's going to have a much more, an increase around 40% in DECAM exposures up to sort of recent times, longer baseline. And most importantly, it's going to have sort of an improved iterative source detection. It's going to have PSF photometry, which the DR2 does not have, and is coming potentially in late 2024, but surely 2025. So the project that I'm going to be talking about is stellar variability in the NSC. So one of the things that we haven't yet touched upon for the NSC is, we have a huge amount of archival data and publicly available data, but we haven't yet explored the full effort the full advantages that this proposes, which is in part being able to sort of use that for stellar variability studies, and more importantly, the ones I'm going to talk about is sort of RLRs and Cepheids, since these are sort of standard candles that we can use for galactic archaeology studies. So we recently set out on an effort to sort of extract as much information as possible from these, and we have set out a few goals for us to work on. So first of all is, so being able to create sort of an automated pipeline that uses the NSC data, the publicly available data, to create a catalog of variable sources. And in particular, we're interested in all of these stellar variability types, so RLR, Cepheids, Eclipsing binary, etc. Then we can release these catalog and can be used by the community. And then we also want to provide some sort of calibrated pure luminosity relations for these types of variables that can be used as standard candles. And this is also going to be good for us because, at least for us, we're going to want to prepare for the upcoming efforts of Rubin. This is going to be a good work for us. So So right now we have these goals currently working on, and there's you know these they're detailed in this presentation in this slide here. Basically, I am working on sort of deriving new calibrated period-master relations for Ceviet and RLR using the NSC band. So one of the things that we noticed that we had an issue with is that most people use sort of like period luminosity relations that are not specifically calibrated to the NSC, or most importantly for DECAM bands, most people use sort of older SDSS bands for these sort of works, and we want to provide sort of an in-house calibrated limit relation for these types of stars. So I'm going to talk about this in this presentation a little bit later. But I want to mention the efforts by the two grad students that are working on this. So these are sort of they're starting their projects now, so it's a little bit of a early on, but we have basically two main things that we want to do for them. One of them is going to be sort of testing different period estimation techniques to know what's best given the characteristics of the NOIRLab source catalog, where we're using archival data, so we don't have sort of a specific cadence in the search of variable stars. So we have to make use of sort of sporadic data that is maybe not thought for variable stars, but we can still extract some useful information. And so the idea is, test how well these methods work. And the other one is sort of use machine learning techniques, which we've mentioned many times during this conference, and we'll probably hear a lot more, to sort of classify these stereo variability types and sort of discern eclipsing binaries, for example, from RLRs and Cepheids, which can be used as standard candles. So as part of this effort, we are developing this sort of code that we want to, or library that we want to put out to the public. So we're going to call it Levit, or we're calling it Levit. And so I've been recently sort of building it up a little bit. And basically what we want to do is sort of provide an easy way to access the NOIRLab source catalog data and use it for these sort of stellar variability type studies. And so tomorrow, I think David is going to do a little bit of a demo on how to access the NOIRLab source catalog data. And I have a little bit of a notebook here prepared if you want to sort of download the data, run a simple sort of Lomskargel method to get the period, and then plot a light curve for a specific source in the NOIRLab source catalog. So in the future, we're going to add a few more things to this library. We're going to escape on and move to the efforts that I'm doing for the period luminosity relation. So as I mentioned before, one of the outstanding questions we have is that we don't have any specific NSC calibrated period luminosity relationships, and this is something that we're going to be focusing on once we have DR3 and we're approaching sort of DR3, because it's going to have a slightly different tuning of the different bands. But for now, I've been working on sort of a methodology to extract these period luminosity relationships. So ideally, what we want to do is take advantage of Gaia DR3. Sorry for the loud. Gaia DR3 distances and parallaxes to be able to get sort of an independent measurement of distances to get the period luminosity relationships. So we cross-matched our NSC DR2 data with Gaia DR3, and we found many matches for sort of RLR stars. So this is sort of RLR stars as classified by Gaia, and maybe not so many matches for Cepheids, or not enough matches for Cepheids that we could sort of run that we could use parallaxes or parallaxes that had good enough quality to sort of derive distances from. So for now, we're using these two different approaches, one for RLR, in which we do use parallaxes, and then one for Cepheids where we calibrate it based on the already existing sort of Gaia pure luminosity relationships. But we hope to have a better understanding by then later on. So this is sort of how the cross-matched RLR and Gaia stars look like. So they're mostly located in the galactic bulge and the two MCs. So I'm going to take sort of maybe an unwise parenthesis here that I was thinking about just before coming in here. So I mentioned MCs, and there's currently an ongoing effort to sort of move away from the name of these two galaxies that we've been using for the past many years. So there's a resolution by the IAU. So if you're IAU member, I think this coming summer, you can vote on changing the names for these galaxies. So we're trying to move away from sort of naming them after pastime conquerors to maybe use a new methodology that doesn't exclude as many people. So close parentheses here. So yeah, so for the RLRs, we use parallaxes, and then we obtain these are sort of preliminary pure luminosity relationships. So for most of the time for pure luminosity relationship, you want to use sort of the redder band possible. So we have here G, R, and I bands. So most of the times you want to use the I band if you have it. So for the I band, we actually do get some sort of reasonable estimate of the pure luminosity relationship, and I've compared it to SDSS derived pure luminosity relationships and fits well. So I'm going to move quickly to delta Cepheids, and delta Cepheids we use all distances derived using already Gaia pure luminosity relationships. And again, we mostly see them being concentrated on the MCs and the galactic bulge. So we also are able to derive these pure luminosity relationships, also sort of preliminary. So if you want to look through them later on, we can maybe put those up somewhere else. So we do that for, in this case, fundamental mode, separate from the first overtone Cepheids. So in the future, we want to sort of refine the methods of looking for these variable stars in the NSCs, which to be able to get more of these stars to use as calibration, and then improve sort of our template fitting, and in general, be able to repeat this analysis with DR3. So I think I'm out of time, and I'm just going to leave the conclusions here, and thank you.